podcast, and I'm going to share some information on the Thunderbird, and hopefully it'll help you if you're designing your own model. Maybe some of the stuff that I'm doing you can incorporate into your model. And if you have any questions or want to do that, I certainly have no problem answering questions if I can. But let me first go over a couple of things. Now, with the ornithopter, this particular one being a Thunderbird, it is a little different than the ornithopters that I've seen in that it does not use an elevator servo. And from time to time I'll get an email asking me about this elevator servo-less ornithopter. And so I thought I would share some of the information, and if you go all the way back through the videos, you'll see that I think it was video number 21, update number 21. At that point I stopped using an elevator servo. So I can do that because of the way that I fly it. So you wouldn't fly this like you would probably the average ornithopter. However, if you fly it the way that it was designed to be flown, then number one, you won't miss the elevator, and number two, it's very maneuverable, believe it or not, without the elevator servo. So the difference in the Thunderbird is the fact that in order to go up and down, you control that with a throttle. Turn right and left, you use the right stick or the aileron. And the battery on this particular model, on the Thunderbird, the battery is going to go toward the rear. Now I'm using two different batteries depending on what I want to do. If I want long flight time, then I'm going to use the 1800. Now this is a 40C battery, and I try not to buy anything less than a 40C battery, mainly because it works the best. It offers the most power or the most punch. So, but with the battery's going to go near the rear. Now in the previous videos and all the testing, the battery was up here somewhere. But I figured out over time and the testing that the best place for the battery is near the rear. If you notice the logo, the battery sits about a ½ inch in front of the logo. So if I'm using a 1300 milliamp battery, it's going to set right there. If I'm using the 1800 milliamp battery, it's going to set right there. So, and you notice that I have my Velcro, the Velcro strip that I put back here used to come all the way up, but now I just use from about the first mark going back that way, and you can stay about a ½ inch in front of the logo. This little insight is dealing with the rudder, and as you may have realized, I have done away with the elevator. I don't really need the elevator, and the technique that I've been used to fly seems to be working really well. So for that reason, I've done away with the elevator. That's one less thing to worry about, and plus it saves a little weight. The first step you'll need to do is to go ahead and locate your horns, and then you're going to center the horn between this step right here. In this piece there is a step, and so this horn actually centers on it. Now it can't center right now, it's going to rock because of this step. So what you do is you take your horn, you take a look at it, and you're going to trim these ears, just the smaller ears, so that they lay inside of this pocket here. And you want them fairly tight. They don't have to be a press fit, but you don't want them really loose either. So you can, and if you get it really loose, it's okay, not a big deal. But the idea is we want this to be laying flat up against the back portion or the longer of the two pieces. So as long as we have it flat, that's fine. All right, the next thing is go ahead and take your horn, and with the kit you're going to receive 4 different stars here. And the idea behind this is to first you got to locate the right one. And what you're looking for is one that'll actually slide over the bottom shoulder of your horn. And here I have it. This is the right one. Now, let's make sure that I don't have a second one, because I have a feeling that we may have a second one. Yes, this one here, and it will slide on. You see it went on. It's actually pretty snug, but that's what we want. It will go on. This one
is a little smaller. You notice this one here was larger. The whole idea behind these is if you don't have one that exactly fits, there should be one that you can alter in order to make it fit. And the idea is you want it to be snug. You want it to be a pretty snug fit. Okay, so once you put this on, what this does is it gives added support to the tail. So now what we do is we take this and mount it to the servo and center it so that it's on correctly, and you want the ears to be setting, the shorter ears to be setting vertical. So the wide piece is going to go left and right, the short piece is going to go vertical. And so the idea behind this is to go ahead and whenever you mount the tail, you'll do it with 4 O-rings, and you will simply O-ring this in place. Now the O-ring does not grab the servo horn. The O-ring actually goes over the servo horn and goes back around and grabs the back side of this plate that we put on. So it doesn't matter how big your horns are, it doesn't matter how long they are, whether they're real short or really small like this. Either way will work, and either side will work. So you're just going to set it on and then O-ring around all the way to the back side. Something really simple, but it adds a lot of support to the tail and a lot of support to the rudder horn. I'm going to show you how to remove the tail, and actually this tail is easy enough to remove that anytime I work on the model I go ahead and remove the tail. First thing you do is remove the 2 O-rings on the upper and lower, and then the left and right side I simply will push the ring out with my 2 fingers going in that direction and over the horn, and then pull it back over the horn, and now my tail is removed. To install the tail, I do exactly the opposite. So first thing I do is lay the tail up, stick it on one of the horns, pull it all the way over, and then take and stretch the O-ring over the servo horn, and then pull it back, and then push it back to center, and then make sure the rings are up against the output shaft, and then take the bottom ring and stick it on and slide it over, take the top ring, stick it on and slide it down, and now the tail is back installed. So you can see how quick it is to take off. Remove that ring, remove this ring, shift the tail over, pull the ring off, shift the tail back over, pull the ring off, and what I do is I just clip the rings back on, and now I can set my tail aside so that I do not damage it by turning the model upside down and setting it on the table. So now I'm free to work on the model. It can lay flat, no issues with damaging the tail. This is a elevator servoless setup, so I only have rudder, no elevator, so this is fixed. You simply loosen this bolt here and loosen this one, and you're free to pivot this. There is a recommended angle. How do you get the recommended angle? You put all the assembly together, tighten the bolts up so that it is snug, but yet you can still move the servo mount. You set the model down on a flat surface with the tail mounted, obviously. You are going to take a measurement from the base of the table, or the top of the table, the flat surface, up to this point. You want to set this angle so that right now I'm flying so that the angle is set at 8 1/4 inches. So I measure simply from the table up 8 1/4, and I move the tail until I hit the 8 1/4 mark. When I have that, then I lock it down, tighten everything up snug so it doesn't move, and go out and fly it. Then from there you can make an adjustment whether you want a little more or you want a little less. 8 1/4 seems to be working fine for me, and I'm happy with it, and I've see no reason to be changing that number. So 8 1/4 inches is what I use when the model is flat on the table, and then measured again from the table up. 8 1/4 inches.